Welcome to Farnborough Connect's new Global Urban Air Summit 2.0. I'm Marion Blakey, and I'm joined here by Eric Allison, head of Uber Elevate. I have to tell you, I've probably met a number of you all here, one way or the other when I think about Farnborough. But just to be sure, I'm Marion Blakey, as I say, have been the head of Rolls-Royce North America, the big engine folks. I have also been the head of the Aerospace Industries Association, and probably significantly at the air shows, the Federal Aviation Administration. Now, Eric, an intro from you.
It's really an honor to be talking to you today, Marion. I'm Eric Allison. I lead the Elevate team at Uber, and I previously helped to start one of the first eVTOL vehicle companies called Zee.Aero back in 2010. And so been learning about this industry from the inside for quite a while, and really excited to talk about where it's at today and where it's going.
Terrific. Well, it really is a pleasure to be here with you, Eric. I don't even know when we first met, but I have been very, very taken with the things that you've been tackling. And, you know, I have to tell you, I have been in transportation, as you gather, for a bit, since the early 90s, really. And both in terms of the Federal Aviation Administration and even the National Highway Traffic Safety Administration. I was very pleased that things from the standpoint of the various modes of transportation are beginning to blend. And it was great to hear that Uber's vision now extends beyond just ground transportation. So how about if you tell us more, Eric, about how that came to be?
Yeah, absolutely. So, Uber has a vision of creating opportunity for people to move, and people to be the lifeblood of movement behind cities, which is very important, not just in the movement of people, but also in the movement of things. And so, we have a vision that the different forms of transportation can be layered into this platform in more interesting ways over time. And so Elevate is an expression of that vision, that we see the possibility of this form of aerial ride sharing, which we've gotten some glimpses of in different things that we've done over the years, really coming to fruition with this new class of vehicles that can do the mission of urban transportation to move people from point to point in a seamless way through the air on an everyday basis. Really is going to come to life, and it's going to happen as soon as we can make it ready.
You know, that's terrific. And I'm really pleased to know that you have created such a good approach to partnering with OEMs, because eVTOLs are out there. Rolls-Royce, my whole company, actually just launched one a year ago at Farnborough. So it's going to be very important to work together, building an eVTOL network. I'm curious because we're thinking about it from an FAA standpoint. Certification is a real challenge. And I'd love to know when we think the first type certified eVTOL might be out there. And of course, has all of this been affected significantly as all of the partners are dealing with the COVID pandemic?
At Elevate, we've taken a pretty unique approach in the industry to how we're looking at this problem. So as I mentioned, our vision is that this form of aerial transportation is woven into the Uber network, is able to be accessed in the same on-demand way that you can push a button and get a ride right now in many places around the world using Uber. And so part of that vision is that we see kind of a web of connectivity being built through technology, allowing us to, when you do that, press a button and get a ride, we're able to get a car, send a car to pick you up at wherever you're starting, get you to the nearest place where you're going to be able to catch one of these eVTOL vehicles, and then have another car meet you at your final destination and get you exactly to where you want to go, and doing it all in a transparent, technology-enabled, behind-the-scenes way that can create a magical journey effectively. That's that feeling of how it just works when you do a time transfer between two trains and it actually works out. But creating that experience, that opportunity on a daily basis for people to move seamlessly between modes in a single journey every day. that's part of how we think, or maybe the key enabler to bring this technology to life and bring it to lots of people in the near term. But to do that, we're not vehicle manufacturers. So we're not designing, we're not an OEM, we're not designing the hardware, the vehicle piece of it, as interesting as that might be from my previous work. But what we've decided to do is that we want to partner with those who are really, that's their wheelhouse, that is what they're good at, that they have the experience, they have the knowledge, they have the background and the relationships and the regulatory side of things to be able to make this happen. And of course, any vehicle that operates in our network in a commercially relevant way, or in any way, it has to be certified. So that is an incredibly important gate that everyone needs to go through. And so we know that is absolutely one of the biggest risk areas in some sense in this whole endeavor. And so that's one of the reasons we've partnered with a number of different world-class companies who are working on these types of vehicles. And we've tried to basically present a vision and a clear statement of what the economic mission of these vehicles needs to be. There's many companies, and I know from my own background, that are working on it, but coming at it kind of from a technology first standpoint, shall we say, that are really focused on the capabilities and developing up the core technologies that are able to make these vehicles work generally in any way. But what's really important, or equally important, and maybe more important in some ways, is that you have the right mission. As you know from your many years of experience in the aviation industry, you can build airplanes to do lots of different missions, but an airplane built to do one mission might not be the best airplane, or oftentimes isn't the best airplane for another mission. And so what we've tried to do is bring clarity to this problem by using kind of the knowledge that we have, building up tools and capabilities to really clearly articulate what the economic mission of this type of vehicle needs to be to work in an Uber network, and do it in an economically rational way. So how fast do these vehicles need to go? How much payload do they need to carry? How many revenue seats? What are the noise targets? It's an incredibly important piece of this whole puzzle. And how far? What's the range? And so many other kind of derivative requirements from that we've worked on as well. But fundamentally, it's about that high level economic mission and providing certainty that if you make an airplane that fits to this basic specification, that we have an application that absolutely will work with it, and you can make money in an economically rational way. So that's the premise of what we're doing. And working with these OEMs, we've built really good relationships across the board. And as we look and kind of and keep in very close contact with all of our partners, we see kind of a different range of effects potentially from COVID. And I mean, as certification is the number one most important thing from a vehicle developer's standpoint right now. Some of the companies are into the certification process already, and some of them are still in the prototyping process. And so the impacts of COVID are disparate, I would say, depending on where you are in that process. If you're working on certification, there's a lot of focus work that doesn't need to be in the lab, that has to be done to make really good progress on that. If you're in a prototyping phase, it's a tougher situation, I think. And so we see a variety of impacts. And then other people who are just in the starting phase, maybe some of the people who are not our partners are trying to raise money to get going. And it certainly we've seen impacts in terms of the way the capital markets are reacting to this overall crisis as well.
Yeah, it makes it a very complicated stew for people who are trying to really take a towel in your ground. And, despite coming from, basically Rolls-Royce is largely into internal combustion engines, although they're doing hybrid electric now. But I really do believe in an all-electric future. So I have to say that at this point, one of the things that I think both in terms of certification and just the pure practicality of this is the question of batteries. I know we've made a lot of advances, but I'd love to know more about your perspective on how that's going and whether or not it really makes a big difference in terms of the environmental footprint we can expect, as well as reliability. I mean, how's an eVTOL going to compare, for example, in terms of noise emissions to, say, a helicopter? And how about a Tesla, just to think about the range there?
We came into this honestly, when I helped to start Z, and when we started going on Elevate, thinking that there might be a pathway in terms of this, again, focus on the mission, the economic mission that we're interested in, which is an urban or semi-urban, on-demand or relatively short-range type of mission, because that's where we see the bulk of the demand that we think can really fuel the economics of this type of a service. Thinking that there would be close between a hybrid approach and an electric approach, and potentially even the hybrid would prove to be the better near-term approach. As we've done more analysis on this and really dug into it further, we've come to the conclusion, pretty strong conclusion, that all electric is actually the way to go right out of the gate. The reason for this is that there's actually interesting ripple effects and consequences of what you choose in terms of a power plant. And one example that I like to point to is infrastructure. So this is a big coupled problem. It's effectively designing a system of systems that the service is the product is the service. It's not the airplane itself. And so we have to think about the implications on infrastructure siting, infrastructure permitting, the cost of building out infrastructure, and how that affects the unit economics of the overall service, for every trip. And we see that going all electric actually has a number of benefits outside of just the aircraft side. On the infrastructure side, we don't have to have liquid fuel on top of potential sites for infrastructure. You don't have to have any concerns about getting fuel to a refueling point, for example, in terms of many of the places that would be very have high utilization and high utility of siting infrastructure. Just some of the examples of the benefits that come from that. And really then the question is, okay, so that's great. There's a bunch of follow-on ancillary benefits of having an all-electric solution. It's actually much easier just to it's much less complex, and so it's going to drive down the overall maintainability costs to keep the vehicles operating at a high level of safety. You give up something, and the thing you give up is range. And the question is the trade-off on range an okay trade-off? Can you be good enough for the mission that we care about while still accessing these benefits of being all electric? And our analysis suggests that the answer is yes. Batteries have been increasing in performance and falling in costs on a pretty steady basis. When I first got into this industry 10 years ago, just to put some numbers on it, probably the best battery that we tested and looked at for the eVTOL mission was something around 180 to 185 watt hours per kilogram in terms of energy density. And what we see now is an equivalent battery, or a battery that's appropriate for this mission, is something like 260 watt hours per kilogram. And so we've seen this steady, significant increase in performance over the last 10 years. We anticipate further increases in performance based on the roadmaps that battery manufacturers are driving. And the cost curve has actually come down faster than every prediction. If you properly analyze and specify the economic mission, you don't need very long ranges. In fact, they won't be used that much. Effectively, what you need to do is be able to operate continuously around short missions for some period of high demand window, which we've laid out in some of the work that we've done. And the batteries that exist today can do that. And they can do it in a way that makes sense economically as well.
Eric, I would really love to hear you talk a little bit more about the environmental footprint. Both we're talking about emissions and we're talking about noise in the foreground. So what do you think?
So when you do the emissions analysis and you take into account the load factors, because it's a shared vehicle that we believe we can achieve from our simulations, and you look at the fact that for many of the types of trips that we think are pretty interesting that people will be taking, we'll be replacing single occupancy cars in a lot of cases. And so we end up comparing pretty favorably in terms of the emissions per mile equivalent of taking this type of transportation, fundamentally compared to what most people are doing on a daily basis. And a pooled, a shared eVTOL compared to a single occupancy Tesla actually compares pretty favorably. We know that in order for this type of mobility to be widely accepted and widely deployed, frankly, the noise footprint, the noise compatibility of these vehicles has to fit into the community. And so what we've tried to do is, one, set pretty aggressive noise targets that are based on analysis that we've done as to what is achievable with a lot of hard engineering, but we think it's achievable, that we've kind of spread with our partners. We've targeted something like 15 to 20 dB lower than an equivalent helicopter. And that's really focused on the vertical takeoff and landing phase of the mission. In overflight, you end up with an airplane because of that same feature of transitioning from a vertical mode to a horizontal flight mode. That the vehicles are not just vastly more efficient in forward flight, but they're actually much, much quieter as well. So you have the topology of the aircraft itself lends itself to that improved noise footprint overall. But we do think it's important to focus on noise even in the highest noise producing phase, which is vertical takeoff and landing, to be significantly better than a helicopter. But we think that's not enough. So we're actually working on what are appropriate ways to think about that type of noise, but in conjunction with a number of operations that happen on a daily basis, and fit that into a perspective on siting skyports as well. What are the characteristics of neighborhoods that you would like to that where we would like to operate, but also where it'd be feasible to put skyports in that operate with this type of frequency. And then we even layer in things like, what is the background noise profile in different neighborhoods? We've done a bunch of work, which we published some of it last year at our summit, around background noise modeling. So we've looked at things like we actually gone out and surveyed the noise, essentially the noise environment in a couple of different cities, to look at what does the time varying noise profile of different locations look like throughout the day, and how does that change throughout the weeks and months. And so that is, we think, pretty important as well, to have that perspective and to look at that aspect of things from a noise perspective. And you put that all together, and if you have the right vehicle with the right improved noise signature, you have the right infrastructure points that have the right design considerations and siting considerations, and you've taken into account things like background noise, we think putting all that together can result in a pretty attractive package that says this is not going to disturb the community, or it's going to minimally disturb the community in which it's sited, and it really provides great benefits. And so that's the approach that we're taking overall to looking at the noise problem.
I'll have to say, Eric, as someone who's fought a few noise fights over years in the aviation world, don't forget early community engagement, involvement into that discussion, because, you know, it makes a world of difference if they feel like they were consulted and a part of the way it all came together.
One of the main purposes of doing demonstration flights generally is to help communities to see this up front, and as part of our overall community engagement strategy, to say, this is this type of technology, this is the benefits that can accrue from it, have a very clear illustration and tangible way for people to understand that and see it in action in some ways, and then couple that with robust community outreach happening as well. We think that is a really, really essential component to bringing this whole thing to life in the near term.
You all are a global industry, and in thinking about that, of course, there's all the question of infrastructure, skyports, how is this all going to come together? But I'd love to also hear about from the regulatory side, because it's a worldwide regulatory system too. And clearly you all have a great relationship with the FAA, I know that. But tell me about how you and your partners are navigating the regulatory environment worldwide.
It's interesting because it is, aviation is a highly regulated industry. And so you have to work hand in hand with regulators in order to make anything happen. And so we've really endeavored to build good relationships, and we've definitely focused on the FAA because that's where we're based. And many of our partners, I'd say the vast majority of our partners, are focusing on certifying in the U.S. And so we want to make sure that relationship is very strong. Just give you an example of the type of work that we've done. We actually have had many interactions on both the aerospace side, but also even on some of the vehicle component side. We put on last year at our summit, we talked about an approach to looking at batteries, to looking at certification of batteries and certain testing approaches. And we're now working with an ASTM committee on putting together a new standard around testing. Around the world, we've actually engaged with a number of different regulators. EASA in Europe, we've had a number of good conversations with. One of our partners, Pipistrel, is based in Europe and actually just got the first type certificate for an all-electric airplane. It was a trainer, but just a short while ago through EASA. And so that's pretty exciting, and we're excited to see the progress there. And certainly the the vehicles will be certified in their jurisdiction, and then there'll be I think that's going to be an interesting process of validation into other jurisdictions, though, because depending on the way the vehicle's certified, there is a bit of a disparate approach that's shaping up, especially between the FAA and EASA on the certification of these vehicles. And so it's something to be aware of.
That's an area where I would hope that perhaps the UN agency, ICAO, could step in and bridge some gaps and help facilitate all of that. Because while it takes a lot to do it, it still might make more sense to have some guidelines and agreement on rules of the road when it comes to the certifications than everyone having to put it together individually. Eric, I really enjoyed this. Thank you very much for thinking to do this today. I'm delighted to be a part of the new Farnborough virtual experience.
Thanks, Marion. I really enjoyed doing this today. I hope that everyone stays safe and enjoys the great content that is coming up.